computer is calculating the millions of the loop, and millions of time it calculate and check whether the duplicates number in it. You see that the brute force code is taking 12 seconds and found the duplicates number approximately 29,000, right? But we can do these similar things in an efficient way. So now let's run this efficient code. Boom, the calculation is done. Only take 13 milliseconds and found the duplication approximately 29,000. You see that writing in a code in an inefficient way may overwhelm your computer, and your computer might not perform very well. That's why performance comes from your logic, not from your computer's RAM. Assalamu alaikum viewers, welcome to VigoSolves. Many people think that computers are super powerful, but trust me, computer is not like a magic box. It has some limitations. If we write the code in an inefficient way, then computers might not give you the appropriate results. Let's see what happens when we write a code in an inefficient way. So first of all, I have created an array called ARR which have 1 lakh elements, and each element is between 0 to 50,000 numbers. So definitely there will be some duplicates in it, right? So let's start the timer for count how much time it should take to compare. Then I have take a blank duplicates array. So if we found any duplicate number in this array, then that number should be kept in this array. So for this I have written a loop, actually a nested loop. First loop takes one number and the second loop compares the every numbers comes after it in the array. So if the first number is matched by the second number in the loop and it's not in the duplicates array, then simply we have added this number to this array. By this way we only logged the duplicate numbers in this duplicates array, and at the end of the time I close the timer and console log the length of this duplicate array to actually know how much duplicates in this array, right? So let's run this code in the Node.js. Now if I run this code in the Node.js, you see that it takes several times. Actually, computer is calculating the millions of the loop, and millions of time it calculate and check whether the duplicates number in it. You see that the brute force code is taking 12 seconds and found the duplicates number approximately 29,000, right? But we can do these similar things in an efficient way so that it takes only few milliseconds. Let's see how I can write the second code. So similarly, I have created an array of 1 lakh elements, and each element of the array is 0 to 49,000. Similarly, I start the timer and create a new set. So what is the sets in JavaScript? In JavaScript, sets is an unique array. So whenever we set something in the set, then only the unique number is added. So if there is a duplicate number, then only one number is added in this set, right? So we can use this feature. So we similarly create the dupes, means the duplicate, in this new set. Now we only run only one loop. So basically when this loop runs, the number is added in the scene set, and if the same number is encountered again, then it is go to the duplicate array. By this way we found the duplicates array in this new set. Now I close the timer and output the result. Now let's run this efficient code. Boom, the calculation is done. Only take 13 milliseconds and found the duplication approximately 29,000. So basically both are the similar operations, but here I use the loop inside the loop, which is a quadratic loop. In the programming sense is big O of n squared That's why it takes millions of time to calculate the same thing. And in this efficient code, we know that the lookup time is almost constant time. So we only need to consider only one single loop. So in this case, the big O notation of the performance of this code is only linear, means n. That's why this code is much faster than this code. You see that writing in a code in an inefficient way may overwhelm your computer, and your computer might not perform very well. That's why performance comes from your logic, not from your computer's RAM. Thank you.